All right, so now we're going to be reading the two-way frequency table. Now the two-way frequency table that I have down here is just slightly different than the one that you just created on the first lesson here, because I have less people in Dallas riding the train and more people walking, but that's the only difference. So it looks about the same as the last frequency table that we just constructed. Now, we are going to be talking about marginal frequencies, joint frequencies, and relative frequencies. Marginal frequencies are the cells that contain the sums or the totals in your two-way frequency chart. So this column here and this row down here, these are considered the marginal frequencies. All right, so if I asked you for the marginal frequency of the number of people in Dallas, you would just say 11. If I asked you for the marginal frequency of cars, you would say 9. Whereas the joint frequency are the initial counts. So that's actually just the middle portion of your two-way frequency table. So that's called the joint frequencies. So if I asked you for the joint frequency of the number of people in Dallas that takes the car to work, you would say 6. And then the one that we're going to use the most is the relative frequency. And what the relative frequency is it's the percentages or the ratios of the data below. And so this can be found by taking either the joint or the marginal frequency and divide it by the total number of people surveyed. So if I asked you for the relative frequency of a New Yorker taking the car to work, or taking car to work, you would do 1 divided by the total number of people in the survey. So it would be 1 out of 30, which comes out to be 3% of people. So that is what I mean by the relative frequency. So we are going to practice marginal, joint, and relative frequency in the questions below. So it says, how many people in this survey walked to work? What we are really looking for here is we are looking for a marginal frequency because we are looking at the total amount of people that walk to work, which if I look at the walk column, I see 9 people walk to work. So my answer is 9. All right. How many people in this survey live in Chicago? I am also finding a marginal frequency because I'm just finding the total number of people in this survey that live in Chicago, and that is 13. Now, I'm not expecting you to actually write the words marginal or joint next to the questions, but the reason why I'm doing this is because I want to show you guys what we're really finding. We're finding the marginal frequencies in numbers 1 and 2. Now, number 3 says, what is the relative probability of the number of commuters in Dallas? So if I ever use the words relative probability, what I'm talking about is the relative frequency. But I'm going to be talking about this as a percentage if I say relative probability. So how I do this is I take the number of commuters in Dallas, the total number, which is 11, and that's going to be out of the total number in my survey, which is 30. So if I do 11 divided by 30 in my calculator, I'm going to round to the nearest percentage. This comes out to be about about 37%. And that's your answer there. That's what I want. And actually, I'm going to write the little squiggly 2 equal sign, the approximately equals, because we did have to round. All right, and so what is the relative probability of the number of commuters riding the train? This, again, I'm finding the relative frequency. And how I do that is I look at the number of commuters riding the train, which is 12, and I put that out of 30. So I do 12 over 30. Which, in my calculator, 12 out of 30 equals exactly, so that's why I'm not using the approximately equals to sign, equals 40%. All right, so how many people in this survey live in Dallas and drive to work? If I'm just reporting the number of people that satisfy 2 conditions of living in Dallas and driving to work, this is a joint frequency. So here I look in my table, my two-way frequency table, lives in Dallas and drives to work means they're taking a car to work. That's 6 people. And then, how many people in this survey live in Chicago and walk to work? So same type of thing. I'm not finding a total. I'm not finding the sum of anything. I'm just reporting how many people live in Chicago and walk to work. That's 5 people in this survey. And then what is the relative probability of living in New York and walking to work? Well, if I'm doing relative probability, that means I want the relative frequency. So the relative probability of living in New York and walking to work, I'm looking at the New York and the walking to work. That's 2 people out of the 30 that were surveyed. That's what I really want to report. So 2 people out of the 30 that were surveyed is going to equal, and so in my calculator I just do 2 divided by 30, and then it gives you, and sorry, I'm going to need to do approximately equals to, it gives you a decimal. For those of you that don't know how to convert your decimal into a percentage, all you need to do is multiply by 100. So that's about 6.7. We'll round to the nearest hundredth on this one. 6.7% of people. And then what is the relative probability of driving, this should say a car, and living in Chicago? So again, we're doing relative frequency here. And driving a car and living in Chicago, so I look at the car, and the number of people that drive a car and live in Chicago is 2. So, and that's 2 out of the 30 people that were surveyed. So actually we already did that in our calculator in number 7. It's going to be the same exact probability here. 2 out of 30 gives us about 6.7%. All right, so that's us practicing the marginal frequencies, the joint frequencies, and the relative frequencies. Now, it says for us to look at the train column. Would it be fair to say that according to the survey, more people ride the train in Chicago compared to New York? Why or why not? Well, if I look at the train column, I see that only 3 people ride the train in New York compared to 6 people in Chicago. So in my mind, I'm thinking, yeah, there's more people riding the train in Chicago than there is in New York. However, if we look at the total amount of people that were surveyed in Chicago and New York, there is a discrepancy here. There were only 6 people surveyed in New York, while there were twice that surveyed in Chicago. There were 13 people surveyed in Chicago. So it may be true that the number of people in there's more people riding the train in Chicago than there is in New York. However, we cannot actually make that conclusion because there isn't a fair, this isn't a fair sample here, given that we surveyed less people in New York than we did in Chicago. So, you guys can kind of summarize that if you wish, but here is my own summary. No, while this could be true, there could be more people that ride the train to work in Chicago compared to New York, we cannot conclude this by looking at this two-way frequency table. The two-way frequency table will not take into consideration how many people were surveyed in Chicago and in New York. So as we can see in the table, you can see that there were 13 people surveyed from Chicago, but only 6 surveyed in New York. Therefore, there were twice the amount of people surveyed in Chicago, which could be the reason why there were a higher number or a higher amount of people taking the train. All right. So once you're done writing that down, this is the end of lesson 1 for levels 2 and 3. All right. Please continue to the next video for lesson number 2.